Hello and welcome back to IXL tutorials. This is Mr. Duffick, and today we are doing IXL K8, which is even more proofs involving congruence. This time though, we are going to be kind of introducing the principle of corresponding parts of congruent triangles are congruent, or cpctc. Okay? And so what that means is you'll go through a proof, right? And you'll get down toward the end, and you'll proof like this with a diagram, and you'll get to the point where you say, well, this can be proven through one of the four congruence theorems for triangles: SSS, SAS, AAS, and so on, right? And that's usually going to go toward the end right here. And then what you can do is once you've proven, let's say all three of the sides are congruent for each triangle, and therefore all aspects of the triangles are going to be congruent. Therefore, you can start writing statements like, well, angle U and angle W are congruent. And we know that because corresponding parts of congruent triangles are congruent. Since we have not clearly stated the certain aspects are congruent, like those angles, even though we have proven the triangle is congruent, that is the reason why we can write cpctc. It's just to extrapolate further. Even though we have proven two triangles are congruent, we can actually state that reasoning right here in the two-column proof. Okay, so just like all the other KIXLs dealing with proofs, they're giving us information and a diagram. So it says X is the midpoint of TV, T and V, so okay. That means this side, or this length and this length, are going to be congruent, right? Splitting it in half. Complete the proof that UV is congruent with TW. Okay, so they already say that we're gonna know that UV and TW are the same because of CPCTC, meaning the statement before is probably going to be one of the four main congruence theorems. Okay, so we'll see what we have, and we know that. Let's see. We know that this is the midpoint, meaning this side and this side are going to be congruent. Okay. What else do we know? We know that angle T and angle V equal each other. Okay, so those two angles are going to equal each other. Great. So we have a side and an angle, and we know that UW, U and W right there, are also going to be congruent. So we have an angle, and we have a side, meaning we're probably just going to do angle, side reasoning. That's how we know both triangles are going to be congruent, because we looked at an angle, an angle, and then a side and a side that are all congruent. All right, next. Two triangles, it says QR right here and TU right here are going to be congruent, so this length and that length. Cool. And since we know the triangles share this this little segment of that side, we know that the entire sides here are going to be congruent, right? This length plus this length, and then this length plus this length, they're going to be the same thing. So we have proven one side. Great. Angle PUQ, so PUQ, this angle U right here is going to be congruent with SRT. So R and U are going to be congruent as well, apparently. Great. So we have a side and we have an angle. And then RTS, and PQU are going to be congruent as well. So T and Q right here are going to be congruent. So we have another angle. So angle, side, angle, complete the proof. Okay. Well, they've already told us that eventually we're going to prove that the angle, side, angle theorem is the one we choose. But let's go to the step here and see what we are doing. So it says we have QU right here. When you add TU and QT together, so this plus this, it's going to equal the entire length. Okay, so what is the reasoning for that? Is it the additive property of angle measures? Well, we're not dealing with any angles, right? These are all just lengths. So we go down to the second one, additive property of length. Yeah, that's probably it, but let's keep going and do process of elimination. All right angles are congruent. Nothing to do with right angles. Angles forming a linear pair, nothing to do with angles. Definition of angle bisector, no angles. Definition of equilateral triangle, nothing to do with equilateral triangles in this entire problem. Definition of midpoint, nothing to do with midpoint there. And vertical angles, again, nothing to do with angles. So very clearly, this is going to be the additive property of length, because again, this is just showing that this plus this equals the entire thing. This length plus this length equals the entire length. So it's going to be that one. Okay. So this one says GH and FI are parallel. Nice. And GH and FI are also going to be congruent. Also nice. Okay. So let's see. No, now they give us two statements to prove here. So we'll go to angle FJI, or FJI, so J right there, and GJH. So these two angles right here are going to be congruent, and how do we know that? Well, let's look at our reasons here. Additive property of angle measure, no. Additive property of length, no. All right angles, no right angles. Angles forming a linear pair, nothing to do with a linear pair. Nothing to do with angle bisector. Nothing to do with equilateral triangles. Nothing of midpoint. But they are vertical angles, right? And we know that vertical angles are congruent or the same length. So therefore, we can say vertical angle theorem for that point. Now we'll move on to the second one. This one is probably going to be one of our four main theories there. So we have triangle FIJ is congruent with HGJ, and why is that? Well, what do we have? We have a side and we have an angle, and what else have they given us? I and G are going to be the same, so they've given us an angle. So we have angle, angle side, okay? So angle, angle, and then side, which is definitely one of our proofs. Angle, angle, side. Okay. Now we have three statements we have to prove at the low score of 50. Interesting. So it gives us this diagram here, and it says GI is congruent with FH. Okay, so same length there. So we have a side. Good. And complete the proof. Okay, so we'll go down to the statement here. How do we know FGI? FGI, so this angle here, and FHI, FHI, in this angle here, how do we know these two angles are going to be the same? Okay, is it the reflexive property or reflexive property of congruence or equality? Equality is for numbers, congruence is for when we don't have the measures of things, so when we just have our letters. The reflective property or reflexive property is just something equaling itself. These are that is not the case here, right? The angle G is clearly on a different part of the diagram than the angle H right here, so it's not anything to do with reflexive property. That would be like G equals G or H equals H or something like that. Substitution. Are we substituting something in from the previous statement? FGI, and okay, so these two are the same right here. And then it looks like we're substituting in FHI for GIH. Okay, so I would probably go substitution here. The key here is we have the same part of the statement, or same part of the, the statement there between both steps, and we only substitute one thing in for another. The other part is the transitive property, and the transitive property is not going to apply here. So there. Down here, HI is congruent with HI. This is a perfect example of the reflexive property. The saying HI is equal to HI, which is very clear. Okay, and because again we are not dealing with actual numbers, the reflexive property is going to deal with congruence and not equality. Okay, and you can also tell because we have the congruent sign there. We're dealing with congruence. And then lastly, our reason is going to be one of the four main theorems here is what it looks like. So how do we know FHI, FHI, so this triangle here, is going to be congruent with GIH, G, I, and H. Okay, so this one is congruent with this one. Well, what do we have? What do we have? We look at all this and it says GI and FH are given, so are congruent. So we have one side that is proven congruent. Great. What else do we have? We have another angle FGH, or GFH, yeah, GFH. That has nothing to do with our triangle though. GIH, GIH. So right here is congruent with FGI, FGI. Nothing to do with our triangle here. FGI, FGI, same deal. GIH, GIH, and FHI, FHI. So these two angles right here are the same. Okay, so that's an angle. So we have sides and then angles. And then we have HI is the same for both triangles. So HI equals HI. So we have a side, let's see, a side followed by an angle followed by a side. And that's going to be the case for both. So it's going to be side, angle, side. Okay. And that is a score of 60, which is where I usually stop with the proof IXLs with my class. So this one only has 2. Wow. Interesting. So that is where I'm going to end the video. So stay safe, study hard, and I'll catch you for the next IXL tutorial. Goodbye.